What could you do with a metal 3D printer? Introducing the Metal X, the easiest way for you to go from design to
Hello, hello. Welcome to Average Expectations. I hope I am sounding okay. Let's just double check. Yep. Okay, so today's going to be a more chill week. That's because assignments are due tomorrow night, so I'm keeping an eye on messages just in case somebody has some questions that pop up during this evening. So anyway, Let's just jump over the quick rundown, just so I get used to doing this. This is Average Expectations. We do AI programming, math, gaming, music, and a little bit of whatever strikes our fancy. I'm streaming Fridays every week from 8 p.m. and some very simple rules here. Basically, be respectful and don't harass people, don't solicit, don't spam, no personal information. And if you are here for course stuff and it's really specific to what you're trying to do, contact me through the official methods. You can still ask me through chat, just don't make it too specific. So let's talk a little bit about some projects. So this was the test stream. And last week we started a 12-tone all the things project where we built a little program that takes in a Midi file and turns that into serial music, which is music that has all 12 tones running all the time. So that was pretty successful, actually. I'm quite happy that we got it all done in one stream. And today, because I'm taking it a little more easy, I'm just going to tweak this, hopefully make it better and put it on GitHub. And then we'll be done with that. Next week will be the better talking piano. So I might do some prep for that at the end of today's stream, just to get ahead for that, because that's going to be a pretty important project for me. And I'll go into more detail when we get there. Now, here, after that project, I've actually got a really exciting idea that I want to try out. So I'm bumping this up the list, and then we'll see what other things show up. But this is the idea I'm going to work on eventually, hopefully after the talking piano one, which is a Dwarf Fortress plus stable diffusion. So a little bit of background about each of those. Dwarf Fortress is a video game that is very immersive, and it's about dwarves. It's basically Lord of the Rings without the elves and humans. And there's only one problem with this game, which is it basically doesn't have graphics that are kind of, that look good to average people. And so the way we're going to fix that is using stable diffusion, which is the AI image generator, which is making the rounds on the internet. It's basically the next big thing. And so we're going to basically hack stable diffusion into Dwarf Fortress, hopefully, and make it a graphical game. But that's a little down the line. And the reason why I'd like to do this project soon is because I'm actually taking a course on generative models right now, so this is very relevant. However, the talking piano kind of needs to happen first because I need this for composition work. So yeah, that's the order in which things are happening. And plus, this 12-tone project has been really relevant for doing this talking piano. So with that out of the way, let's jump into today's nonsense. Got a slightly different background on today. Yeah, all of my desktop backgrounds are from the amazingly beautiful game called Greece. Really identify with it. Anyway, so today I've got, let's see, here's the code from last week. And it looks okay. There's a couple things I don't like about it, so let's go through it and kind of make a little wish list of things to fix. So, let's see. So this part's okay so far. Here we've got an issue of we haven't really handled chords yet, so maybe we should do that. Basically, at some point in this process, you have to split notes between tone rows, and the question is, what happens when two notes happen at the same time? Which note goes to which chord? Which tone row? Well, there's really, right now we're leaving it up to the machine to chance. So maybe we need a way to do this more intentionally. What else? Well, we've got a hack here right now, which is that the last notes of the piece, which don't belong to any particular group, they actually don't get mapped to anything right now. They don't get changed. So maybe we should deal with that. copy all messages. Okay. And oh yes, I remember this. So there was an issue with using tracks where basically if you take all of the messages into one track, and all the duration messages become floats. And that's not great because the Midi format requires integers. So we need some way to, if we're doing this, we need some way to turn it back into integers. And also, ideally, we should track which track each note comes from so we can put it back in the correct track instead of having them all mashed into one track. Okay, so that looks like it. I would also like to get rid of some of these hard-coded things. Maybe we'll make it a command line argument instead. A GUI is kind of out of the question, so I was thinking maybe there should be a graphical interface for this program, but that's a lot of work and might involve, like, maybe I'll rewrite it in JavaScript at some point, but whatever. For now, we are going to just leave it as a command line thing. Okay, so let's just write down the goals for today. Wish list. Okay, so I already did this pre-stream just so that I knew what I was doing. First things first, there was a Midi note off issue where we weren't catching the ends of the notes. So all the notes that we found, they just rang forever. That doesn't sound great, so we're just gonna fix that. Next, this was the chord issue. So basically, sorry, no, this is the track issue. So we need a way to bring together all the notes from various tracks and then put them back into tracks. This is the chord issue where we have to choose which note goes where, and then match motifs. Oh yeah, these are just improvements to how the thing sounds. Which is kind of funny because it doesn't sound great by design. It's not supposed to sound great, but we're going to try to make it as musical as possible, which is to kind of improve the way it chooses which patterns to match to which notes. Okay, and finally, we could try adding some other scales. That shouldn't be too hard. That should actually be quite simple to handle. Handle tremolos. So tremolos are where two notes repeat really fast, and so in that case, you should really treat them as just two notes instead of a billion different notes. And so in that case, it won't change notes when that happens. And last thing is to publish this whole lot to GitHub, and if we have time left over, I will do some setup for the next talking piano project. So that's the plan for today. It's always good to have a plan because, you know, memories are fallible things, and my memory is more fallible than average, so it's very important that I write down what I'm doing, otherwise I'll forget. Okay, so let's do some cleanup of the code. First things first, I know I said publish to GitHub last, but I would like to publish what's working right now to GitHub. So, or at least like set up the Git repo, you know, the repository, so we can store this. So let's do that. I will make a minor change, which is I will create some command line arguments, so I'm not passing in these files by hand. Okay, so let's do that first. To do that, we need to import a Python library. Import argparse. So argparse is the command line argument handler. So I think you can do this. Argument parser. And then parser.add arguments. So we're going to add an argument for the file, the Midi file. That's the source. And so that'll be like source or Midi. Midi, source, input. Let's just call it in. Yeah. Then the type of this is path, actually. And I think path is it a type here? No, it's not. So we're going to also import pathlib, right? So this is for file paths, so that they're not just strings. They can also be manipulated intelligently. So a string is just, some characters, but the path is not just a bunch of characters, but also like the functionality that tells you what to do with those characters to turn it into, something that the computer can find on your disk. So that's your input, and this is going to be required. We definitely need the input. And actually, I wonder if there is a way to make a short name and a long name. So we're going to have a long name of input and then a short name of I. Okay, cool. So that's the first argument. And basically to get the arguments you call parse args, right? And then you set that to arguments. And then now to get this file argument, right? We just need to go here and say args dot, and I called it input. So it should be there. And okay, so that means we don't need this one anymore. I'm going to comment it out just in case. We might need it in case things break. So that's that. Combine tracks, that was a flag. So I used that to basically choose what to do with the tracks. Currently, one of these options doesn't do anything. I think currently it just goes straight here, right? So it has to be false. So that's fine. We will add a argument for this because later I'll want to be able to set this flag. So we'll call this combine tracks, and we won't have a short one for this. This one's going to be optional, so we can have a default value, which is bool. Oh, sorry, not bool, false. What am I saying? And the type is boolean. So now here's the thing. Right, I forgot about this, which is argparse doesn't really work well with false and true booleans. So instead, we'll make this a flag. So basically, when it's set, when this flag is present, it will be true, but otherwise it will be false by default. So I think that's an action. So the action is set false, set true. Okay, this is where I need to pull up the documentation for Python. So we're gonna search up argparse action store false, store true. Actually, now that I search it up, there it is. Yeah, so it's just a string called store true. So when this thing is here, when you pass this in the command line, it will store this as true, otherwise it will be false. Okay. Cool. And let's just call this, yeah, okay, this is fine. So similarly, I'm going to comment that out for now, and I'm going to call this args.combine tracks. I believe it should turn this dash here into an underscore. Hopefully that's the case. Okay, so that's almost everything. I also need the file here. So this is where it's saving to. Right? So let's get rid of this part. So it'll ask for the MIDI file from wherever arg's input is, and it will output, to something else, which also is specified by the user. And that way, there's no confusion as to where everything is going. So, oops. So this is args.output. Okay, cool. Quick check for messages. No messages yet. Good. So with that, we should be able to run this. And let's just give it a shot, I think. Let's put it back. Okay, so here's my lovely shell. Where am I? I am in my home folder. I'm going to change directory to the project folder. There it is. And I'm going to run first. Before I run anything, I need the Python environment. So let's get that. There. Okay, now I can run Python Schönberger, and if I just run it like this, it should fail because I'm missing the required arguments. Yes, so you can see it's requiring input and output, so let's do that. Input is going to be, let's see, I need to find the files first. ls, let's search Midi. Yeah, there's a whole bunch. So I'm going to try this one because I didn't do this one last week. Okay, so let's do that. Input is Midi in the subfolder, and then the Chopin. Hello. It's not autofilling. Okay, so I'll just copy it. Okay, this shell doesn't work the same way as my usual shell in Ubuntu, so I'm just going to type it out. It's annoying, you know. I think computer scientists must hate typing because they invent all sorts of ways to avoid typing. Now the output I'm going to put here, I think. Actually, I have an out directory, so I'll put it in out and I'll call it Chopin 12 tone. Okay, so that ran. That's great. And of course, all these messages are from one of the issues, right? It was from the note ending issue. So hopefully we'll fix that today and there won't be all these messages. Okay, that's fine. So, last thing to do, let's just see if that worked. So I'm going to copy over that file to somewhere where Windows can see it, and then I can try running it. Out, 12 tone, we're gonna copy it over here. Okay, so now today I'm going to try running things using a slightly different program than I was last time. Last time I was just using Windows Media Player, and the problem with Windows Media Player is it wasn't reading some of those MIDI files. So I'm opening MuseScore instead. There's MuseScore. Okay, this is a music notation editor, and technically it's not going to be reading these MIDI files exactly as they are. It's going to have to convert them because MIDI is a lower level format, right? It gives you timings, like exact timings for when a note should be performed, whereas this is about writing down a notated score, and a notated score is basically like writing for music, right? Sheet music. So when you do it that way, the difference is that like it's abstracted to some degree, right? Instead of having very exact timings for when things are played, it's going to be kind of more idealized, right? So the actual performance might push and pull a little bit, but here in your score, it should be exactly, very regular. Wow, that's a really weird way to try to explain scores. It's, how would I describe it? It's like the difference between having a play written down and a play acted out, right? That's the difference. So this is the play written down. However, I'm just using this to try to play this particular MIDI recording. So let's give it a shot. Let's play the original first. So I have to fix some things about the way it imports this because it's trying to make it, as I said, a score, and I just want the MIDI sound to it. Okay, so if I do this, it should play. And before I do play it, I'm going to open up the synthesizer. So this guy is what actually produces the sound, because MIDI doesn't tell you how things sound. It only tells you when the notes are and where. So let's play it. So the timing's still a little off, probably because of the translation into the score. But it's close enough. You get the effect. It's a beautiful piece, by the way. Yeah, Chopin's favorite work, actually. At least according to some people. You know, anecdotally. Sometimes it's hard to tell with composers. Okay, so let's hear the messed up version now. After it's been through the 12-tone ringer, it should sound quite different. Let's give it a shot. Okay, that's way too fast. Okay, that's a little weird. I mean, it should sound similar, so I'm quite surprised. That does not sound similar at all, huh? I wonder if I even got the right one. Okay, maybe I converted the wrong piece. I'm going to just try. Yeah, should I try it? We'll come back to it. That definitely did not sound like the right piece. Actually, no. I want to fix this right now. I don't understand why. Like, that's definitely not the same piece, right? You can tell because the rhythm's all wrong. So the 12-tone process should change all the notes, but it shouldn't change the rhythm. And you can see these are not the same rhythm. So let's go copy this back over. Oops. Yeah. I'm going to try loading this guy. Yeah, I see what happened. I moved over the wrong file, I think. Okay, let's see if this is the right file. Yeah, okay, so I think I just copied the wrong file. Let's try that again. Back to this. So I'm just gonna make sure this is the correct file. Here's the original. Yeah, that looks like the right file, I think. Especially if I turn off all these things that import it more like a human. Yes, that's the right file. So now that I've got the right file in, I'm going to run that program again. This guy. So I'm just repeating the exact same command. And let's see what happens. Output 12-tone. Okay. It's again taking a moment. Okay, we throw away the old one. Yeah, okay, now it looks different, right? Yeah, I see. So you can tell it's the correct piece now because just look at the start of this. It's got one note to start instead of a whole bunch that were here. So that matches up with this guy here, right? This one here. Yeah, okay. So I will turn off all of these import options so that we get the closest thing to the original. There it goes, and let's hear it. So once again, here's the original. Okay, and here's the messed up version. So it's still too fast, but you do hear the melody. Let's slow it down a bit. There should be a way to slow it down. Probably in the synthesizer. Nope, only has volume. Okay. Yeah, I don't use MuseScore normally, so let's just throw in a metronome marking. That should fix it. Tempo. So that should be probably the right speed. Let's hear it. It's a little too slow. That's close, close. Wow, that sounds terrible though. Holy moly, it's like 2 skunks in a bag, as my old piano teacher would say. Okay, it's funny because I've played this piece a lot in the past, so, you know. That was actually pretty cool right there. That didn't sound too bad. This does not sound good though. The rest of it sounds terrible. Okay, so that worked. That's all we really wanted to do here, was make sure it works. So now that we've got those quality of life things in, let's create a repository to save this. And we don't care about all these, so I'm going to create a Git Ignore, new file. So the Git Ignore just tells Git, which is the version control software I'm using, which things I want to save and which things I don't want to save. So version control is very helpful for software because you want to track, basically, you want to track what changes you make to software, right? So that you don't lose them. And, you know, sometimes you need to go back or whatever. And so it's always a good habit to use version control. I'm going to use it for anything that's code. So I'm just going to not save anything in Midi or out. That's it. That's all we need to do. Okay, now if I look at Git, I have 2 files which are changed, which is the code. You can see it didn't exist before, so the left side is what used to be there, which is nothing. And now the right side is the changes I'm going to put in, same with Git Ignore. So we're just going to add both of them, and we'll call this the initial commit. Add, what should I call it? Yeah, we'll just say add 12 tone converter, command line converter. Okay, I think that's it. Oh, I've never configured Git. Give me a second to do that. Oops. Want my other, where's my other? Okay, I always need some documentation to do this. So git add username. So we're just gonna copy paste. Oops. Hitting all the funny buttons today. You know, this is really annoying. You know, I'm used to having Control V be paste in my other, on my other computer. So here you can right click on the terminal, I think. Let's see. Copy. And then apparently not. Okay, whatever. And we'll type username. Okay, and I need my email. Okay, I'm going to put this private. Git config, email. Okay, I think that's it. So now that I fixed that, let's try committing again. Yes, there we go. So now if I pull up the terminal, so here's just the built-in terminal to VS Code. I can run git log, and it sees, oh, it gives your email anyway. Whatever. This is the channel email, so it doesn't matter much. Let's see. So it tells you when the first commit was, what was committed, and if I actually look at this particular commit, how do you do that? I think you can just, well, you could diff, for example, right? There's nothing different, but if I change something, like if I write test difference and I run this again, you can see it shows you where things are changed now. So that previous version, which was working, is now frozen in time forever. So in case I screw things up royally here and everything breaks, I can always go back and look at something that was working once upon a time. So now that that's done, let's move into actually making changes. Okay, just a quick check. Good, no messages. And now let's check over the wish list. So first priority, fix the Midi note off. Yes, that's a good one to do. So if I recall correctly, on certain pieces like the serialism, last time, what happened was it could not find any note off events of the format that I thought they would be in, and so it was not able to stop the notes at all. So that would be here, right? Currently I have this method, this static method actually, so it's just a function. It checks if MIDI message is note off. And clearly it's not catching all of the note off messages that are possible. So the first thing I'm going to do is I'm going to open up that serialism file and just make sure that it's actually got the note off objects that I expect. Right, so let's jump down here. Right now it's just opening the file. And we can get rid of those commented things. Now, here's my MIDI. And I'm just going to take a look into this. And this is just kind of a hacky way to do it. I'm just going to print out the first couple messages. Print message for message in MIDI, and we will only do this for like the first 100 or so. So let's do it this way. And we'll print out the number of the message too. Okay, and then we're going to break. Basically, we're going to finish the program right there. Okay, and I'm just going to run this kind of hacked down version of the program with the serialism. So the one that was breaking this code. Let's do that. So if I go back to this guy, out, we don't care now, we'll call this. The important thing is the input, which is going to be, I forget where it is, so I have to look it up. It's this guy, Beethoven serialism. Beethoven. Oh, it doesn't work outside function, of course. That's fine. Okay. Cool. So those are all the messages. Now that's kind of ugly, so let's just separate everything with a new line. And I'm basically looking for some kind of note off message. That because previously I was looking for note on with a volume of 0. And that's clearly not what's going on. Okay, that didn't really help for some reason. Okay, there's an easy way to do this. I'm just going to unroll this loop. Okay. Lovely. Okay, let's take a look at the notes. So we start with a bunch of meta messages. Those control how the MIDI tracks will be handled. So I'm going to ignore those for now. And we're just going to skip all the way to here. Okay, so it's pretty clear what's going on now. This is what I suspected. So previously I was only looking for note on, but you can see there are note off objects here as well, and I haven't been looking for those. And so let's see what goes on here. The important thing is, of course, the note, right? This is actually the pitch we care about. So it doesn't matter what the numbers are. We're just looking for matching ones. So here, we have, that's kind of weird. You notice this is time 0, but this is not. Okay, that's strange. But what is very clear is that these note ons and offs look like they're paired up. That's the important thing, right? So you have a note on, and then later you have a note off, and what matters here is that the note is the same note, and it's the same channel, so those should match up. This should be the end of that previous note, and this one should be matched up here. Okay, next one is note 75, and that is paired up with this note off message. Great. There's only one problem, which is this guy, which has a time of 0, you can see. What is going on with that guy? Does it have a note off message? Yes, it does. Way over here. Okay, so if we look for these note off messages, that should fix that issue we had. So let's do that. Oops. I'm gonna leave that print message in for now. Okay. So where do we do this? We need to go all the way up to is note on, and here you need to change this. So currently I'm looking for something called note on, but as we said, there's also note off, right? So this is one option. So I'm just gonna create this, and then I'm going to create a new option, which is when message.type is note off. And now here I need to make sure the well, actually no, it only checks if it's a note off. Sorry, and I need to put this in note off, not note on. Right. Okay, so something like this should do it. Right, and let's streamline this a little bit. Message velocity, so that's the volume, right? Now for note off events, the velocity could be anything actually. So if you look here, let's see. Okay, here was the first note on. Here is the matching note off. You can see that the velocity here is non-zero. So we should not be looking at velocity for these note off objects. Okay, that's it. So hopefully after we run this, it will no longer have those error messages here. So currently, when it sees a note on object and it can't find a matching note off for that same note, it will warn you, right? And so hopefully those warnings disappear. In fact, let's just do a real quick test of this. I'm going to actually comment this out, so we're back to what it was before, and then we'll put it back in and compare the difference in error messages. Let me make sure I don't have anything else printing. Good. Okay, so let's try this. Yeah. So right now there's a lot of these orphan note messages, so now we're going to get rid of the comments. So now it should be able to match up those orphans. Let's try it. Yes. Okay, so no more messages. That means every single start and end note was matched up between these. And let's just check if that's the case. So Let's go play it back. To play it back, I need to find that. Here it is. Oops. Out, serialism, and let's go here. Okay, so as a reminder, here is what serialism sounds like for real. The bane of every, music student, really, or music teacher, I should say, because you hear this way too much. Okay, and here's the original one we had, which was the broken one. This had the note endings that did not work. It's pretty funky, but you can hear every note is being held way too long. So hopefully we fix that with the new version, which is this one. Yes. Okay. My favorite part is in the middle, so I'm gonna listen to this right here. Yeah, so when it's got all these repeated notes, it kind of goes nuts. So that's also something I'd like to work on today, is what happens with those repeated notes. There should be some improvements we can do, tweaking how the program works for that. So I'm actually going to switch these two windows around because it's more pleasant to look on this side. So let's see. I don't need that. Okay, cool. So that was the first fix, right? Which was fix MIDI note off. That's done. So I'm going to write done. Let's cross it out. I never use strike through. That's very satisfying. You have a to-do list, you can cross it off. Okay. And let's, while we're at it, since I'm using Git, let's publish a change. So what did we do? Before I do anything, I'm just gonna make sure that's cleaned up. Okay. What did we do? Don't care. Okay, so here you can see what changes we made. The only change was to the note off, and that's it. I also got rid of some superfluous comments, but now that I'm thinking about it, before I actually commit, I should probably make sure that it's working as planned. Yeah. Okay, so the reason why I'm saying this is there was another piece, another MIDI file that it was not working for. And I haven't tested that one yet, so let's do that real quick. I think it was the Turkish March, so I'm going to test that right now. MIDI. Let's see. Mozart. Turkish March. I think that's the one. Yes. Okay. And output, we'll call this Mozart. Okay. That's a good sign. No error messages. Let's check it. Out. Turkish March. Okay. So here's the comparison. Project 1, here's the original. Okay. Here's the old version, which was broken. Also, the timing is off, so I'm definitely missing some kind of information about the tempo or how fast it's going. when I do this kind of copying back and forth. My guess is the track information stores how fast each track runs, and I'm not saving that over from the old tracks. Okay, so that's the old one. This should have fixed it by having the sounds cut off at the correct time. Yes. So they don't keep sounding anymore. That's a good sign. Okay, great. Still sounds awful as ever, but at least it sounds more accurate to the original. Cool. So that's that. I'm just going to publish that fix I'm just going to update my repo, my local repository with that fix, and then I think I have to answer a student's question, so I will pause right after this. So let's just update this first. Fix MIDI note endings. Yeah, that seems reasonably descriptive. Okay, we're done. And now, if I look at our Git log, oops. Sometimes my keyboard shortcuts don't work here. Git log, you can see, yeah, so here's my first commit, here's my second, excellent. Okay, I'll be right back because I gotta answer a student question, and yeah, and then we'll fix the next thing. Okay, welcome. Welcome back. Sorry about the wait. That was a rather long answer I had to give out. It's like it's really easy to answer a question when it's like okay, you got it right. You just say yes, that is the correct answer. But when it's like a little off, then you have to really think about, okay, what's the best explanation for try this instead, right? And that's always a tricky thing, of course. Teaching is really a skill. I think it's a skill that's undervalued in universities. Anyone who's been to a university class with some questionable teaching knows this fact, which is that professors and TAs are not hired by their ability to teach first and foremost. That's definitely a secondary concern in most places. I've had some amazing professors, but also some less than amazing ones. Let's just put it there and not go any further. Okay, so let's see, what the heck was I doing? So let's see. So okay, this is why I write things down, right? So you don't forget what is going on. So the project is the 12-tone machine called the Schönberger. We are turning regular pieces of music into this kind of serial or 12-tone music, which is music that sounds quote unquote bad. And basically we are doing this through math, which is using this notion of a permutation. Oh yeah, and I see on the messages. Yeah, I just checked and answered on Slack. Thanks for dropping by the way, Ish. Yeah. So yeah, you can check my answer right now. And yeah. So back to this. So we are. Let's see. We're using permutations to solve the problem of converting regular music into 12-tone music. And that's because 12-tone music uses every note in the 12-note scale once, which is a permutation. And we can solve this kind of problem using something called linear sum assignment and a loss function. And today, I think the next job here, if I go to the to-do list, we just fixed a bug with the Midi notes going off. So now we are identifying the note on and off positions correctly. That's great. Next, we are going to deal with multiple tracks. Yes. Okay. This is going to be a little tricky. So let's see. First off, we need to deal with the problem where we can combine multiple tracks together. Which basically you can see this to-do message here. It says we need some way to convert the time between like floats and non-floats. So what's the best way to do this? Okay, I might have to look up the Midi specification for tempo. Midi tempo. Okay, let's do some searching. Midi tempo messages. Ooh, I like this. Stack Exchange. Always good to go to Stack Exchange. My goal is to currently change the tempo of the song. Yeah. Okay, where is the tempo information stored? That's what I need to know as well. This guy. So let's see. Change ticks per quarter or all delta times. So delta times were those like floats that I was dealing with. Or the integers, depending on how I pulled out the data. And we need to not change that. I prefer not to change that. I would prefer to change this instead. There's also some set tempo events. Okay, so let's print off that file again. So I just want to print off some of this MIDI file to see what's inside it. And you know what? I keep doing this. So let's actually just create a new function to do this. When in doubt, abstract it out. So define a new, we'll call it print MIDI file, messages, and we'll take in a MIDI file, MIDI file type, and we will also take in a total number, because I don't want to print everything. These files are really long. So let's have a max number, which we'll set to 100 by default. So only print the first 100 messages. Maybe it will have a start and end too. So let's change this to end so I can change it to include a start point later. So this is very simple. We're just going to iterate over the messages in the file and print them. I'd also like to know what number. So previously I was looking for note off messages, and now I need to look for, I need to make sure this is working. Yeah, okay. Something's going on here. Interesting. Okay, some weird things happening with my stream. Okay, so let's see. So previously I was looking for note off objects, and now I am looking for tempo objects, so I can manage those. So let's just run this, and there's a lovely list of the first 100 MIDI messages, and now we care about these control ones, right at the top. So now I don't care about the note on and off ones. I care about these. So meta message, time signature, numerator, denominator. Okay, those don't matter too much, but I think what does matter is clocks per click. So this should tell you how long the beats should be, I suspect. Key signature doesn't matter for our purposes. Tempo does matter. So this message, track name doesn't matter. Text doesn't matter. Program, control changes. I don't even know what these are. So again, doesn't matter. I think what matters here is tempo and time signature. So what I'm going to do is check over the file that was converted, the generated file, which is this guy, mozart.mid. And if I recall, it was a little too slow. So now I'm just going to use, I'm just going to take the output of this program as the input. So it should be under out mozart.mid. Okay. So we're basically looking for differences. And you know what? There's an easier way to do this. Now, you could use diff for this, which is a program for comparing two different text files, but I'm just going to do it a slightly hacky way. I'm going to split my screen into two and just call each of those things on each side. Basically, I'm going to print out two different things, one on each side of the screen. Oh, I have to reactivate my environment and all that. Right. In is, on this side, I'm going to use the original. Oh, and out needs to be something. Okay, cool. And then on the other side, I'm basically going to run the exact same thing, which means I really should copy this command. Can I even copy here? No, because this is frustrating. So something annoying about this shell script, this shell I'm using on Windows is that it doesn't see. I don't know what the key bindings are for copy paste. So I'm just gonna have to copy it out manually. So here I'm going to take the output file, and out is going to be just something random. Doesn't matter because it's not going to run that far. Okay, so now I've printed out the first 100 messages on each MIDI file. So I'm just going to compare them. Oops. Cool. Okay, 0. Oops, right here. Okay, so this guy 0 is the first message, and on this side it's a little higher. So I'm just going to align them. This is like old school diff. This is what I used to do before I knew how to use the diff command. Like in high school or something. I just like, your visual system's amazing at tracking changes. So a trick is like if you're trying to identify a change between two images or two text files, you can just line them up and just like alt tab between them. So if you switch between them, you can see the differences. So here I'm just looking to check that I've got the same time messages here. So it does look like that's the same time, right? Time signature, clocks per click, that's all the same. And then the key signature is the same. The set tempo message is the same. The tracks are the same. Yeah, that makes sense because I thought I did copy over every single message. So I'm really confused. Oh, okay. Look here. Okay, here's the change. So actually, it wasn't the it was not the time signature that changed, but rather the individual note timing commands that have changed, right? So here it was 0.5 and here it's 1. So somehow things got changed in translation. Now, I don't know how the library I'm using works. That's part of the problem. And so let's see. Oops. I'm using this guy. This library called Midi, which imports MIDI files, and it's doing some kind of translation behind the scenes, I'm guessing. So when I open up a track here, let's see, where does that happen? Here. Here. For track in MIDI tracks, I'm copying out the messages, and I'm guessing here, something happens to the length of the notes somehow. So, how to test this? Well, I could just print out what these messages look like in terms of the time component. So let's take this print MIDI messages function, and I'm just going to bring it down to MIDI tracks, and I'm going to print out the tracks instead. And one more thing, I'm going to change the end to something a little more reasonable. So if I go back to the list of events, it looks like the messages go to notes after about message 20. So I only need the first 20 messages or so for debugging. So I'm just going to print out the first 20 here. And I'm doing it for every track. So I'm also going to need to print the track name and that. Oops. Actually, I can't do that because that's not a print message. Okay, so let's give that a shot, and then I'm just going to do nothing else. Let's go try it out. So I'm just doing the same thing again, comparing both sides. And now, why did it print out so many? Oh, there's a lot of tracks. Okay, interesting. Okay, so you can see here. Oh, I see. The MIDI track prints out all of the messages in it. So that's like way too many messages. Oops. But you can see, let's see what's going on here. Okay. Looks like this track is really short. So you can see it's just got a bunch of meta messages. It doesn't even print out all 20 messages because you can see them counting up here. It only prints out 8, and then that's the end of the track and there's nothing else. Interesting. Okay. The other track though seems to have a ton of stuff. So let's see what's going on in this other track here. Oops, went a little too far here. Here's the other track. Whew, what a mess. There's a lot of stuff going on. Okay, a bunch of control changes. Those look the same. Okay, you can tell the notes have been changed. So here, the original note was 71, now it's 70. So yeah, this is definitely working for that end. The times are all the same, so the times are not the issue here. You can see all these integer times are identical, but somehow the speed at which they're getting played has been messed up. Why is that? That's what I'm trying to figure out here. The scary thing about debugging is you just never know when it's done. Like, how long will this take? Will it take 5 minutes? Will it take 5 hours? Who knows? Nobody knows. Yeah. So, yeah, I'm not too jazzed about this problem. I wonder if this track here is having some kind of effect on the time of all the tracks. No, I'm sure if I read the MIDI specification, I'd be able to tell you these things, but who wants to do that, right? I mean, they look the same. That's the funny thing. Like, why would it be different if everything is the same? And the other crazy thing is that when you print off the float times, like basically I was printing off the messages from the MIDI file, and the MIDI file automatically converts these integer times into some kind of common float representation. And so when you do that, you can clearly see that the time has changed. So something in this calculation is getting messed up. It's just a question of where, of course. So, oh, there's some more messages at the bottom. Maybe that's what I'm missing. Nope, that's actually from the same. Yeah, there's only two tracks here, I think. Let me just double check that. So I'm just gonna do some sophisticated debugging, which just involves me printing things out. And let's see. We're tracking MIDI track. We're just going to print out how many tracks there are, you know? And I'm not going to print out the whole thing. I'm just going to print 5. Okay. And let's give it a shot again. So, move this file, move this, and run each one. Okay, yeah, that's a lot cleaner, right? So you can see there's track 0, track 1, and honestly, they look the same. So what is going on here? Maybe there's some data that's outside the tracks. That's the only conclusion I have. There must be some extra data that this MIDI file is storing, and it's not giving it away. So let's go find out where this stuff is. So I'm going to go, let's see, Mido. I'm going to look up the Mido documentation. MIDI files. Okay, about the time attribute. Okay, this looks useful. So inside a track, it's delta time in ticks. This must be an integer. So we came on to that last week. That was an issue last week because what happened was, turns out when you load the messages from the file itself, they give you floats, but when you load them from the tracks, you give integers. So that's something I'm going to fix today, hopefully. Now, the other thing is, let's see. Messages yielded from play. Okay, this must be to actually generate MIDI events. Like if you're actually connecting a synthesizer to your computer, you can have it play in real time. I don't care about that, so I'm going to skip that. Yeah. Ticks per beat. Looks like this is a thing in the MIDI file object. Okay, so maybe I should open up the MIDI file object and see if I can find this ticks per beat property. First of all, I'm going to check for it here. Is there a message with ticks per beat? I don't think so. Yeah, it only says clocks per click. So I don't think that's the same thing. So my guess is the MIDI file itself has this ticks per beat thing, which I'm missing currently, which is why I'm having issues. So let's actually just clear all this. And let's see. We need ticks per beat. So I'm just gonna open up Python directly and just kind of mess around a bit. Import Mido. And we need to load the file, so I need to look up how to do that. MIDI equals mido.midi file. And we need a file, so we'll use MIDI. Actually, I'll use out, because that's easier to find. Out Mozart. I think that's one of them. Yes, okay. There. So you can see that's all the messages in this track. Looks like. Yes. Okay, so I already see it. So you can see that in this MIDI file object, there is this type and ticks per beat. And I'm clearly missing that right now, this ticks per beat thing. So we just need a way to copy those things out. And so here's a quick and easy way to check. So currently we have this MIDI object. I'm going to use the Python command dir to look inside it and see what it allows you to do. Now I could also look at the documentation for this, but again, like who reads the documentation, right? So we don't care about the things with this underscore in front because those are private methods and private properties. So they're things used internally by Mido to handle things. I'm going to instead look at, let's see, add track. Okay, that's how you add a new track. Don't care. Char set. Probably don't care. That's probably something to do with strings. Clip. I'm guessing, I actually don't know what that is. Debug, file name, length, play, print tracks, save, ticks per beat. So I think this is what we care about. This and this, right? This type thing. So the first thing I'm going to ask is there a way to copy out this file so I can manipulate it without having to create a new file? Can I just copy it? Should I even copy it? Because the problem with copying is... Oh, this is helpful too. Okay, so back to the documentation. Let's see. It also says there's a type to MIDI files. So type 0 is single track. Type 1 is all tracks together. Type 2. So this matters. We definitely should save the type of the file, because otherwise the tracks will come in at the wrong times. And what else? Okay, so I think these don't matter. So these are calculated, right? The computer calculates them for you and for your convenience. So I don't need to set that. MIDI file, create. Okay. Are there any other options to care about? I think it's mostly type and this tempo problem. Okay, ticks per beat. Type and ticks per beat. Let's start by saving those out. So if I go back to dir here, we have type as a thing in this object and ticks per beat. So if I go midi.type, okay, gives you the type of the file. That's great. And ticks per beat. 480. Okay, so those are the numbers we need to store. Now, if we go back to the code, where's the code? Okay, so here, this is the original MIDI file, and then down here, I have a new MIDI file, and here I do need to copy out all those attributes. So we have type equals something. Actually, I'm going to use the type hints here. It says we have a file name, file, and type, ticks per beat, char set, debug. Hey, this is handy. Why didn't I do this first? Yeah, so the nice thing is the documentation fills out all this information. I should have just checked here instead of going on, like going through Python, going through the interpreter. Okay, the important thing is let's fill out those key things here. Type equals the original file's type, and ticks per beat equals the original file's ticks per beat. We might as well copy out the rest of these. And clip. I think that's it. Yeah, I don't think we care about the other ones, so let's just stick with those. Okay, now if I run this again on that Turkish march, it should have the right tempo now. So let's make sure that's happening. Okay, it's going to save out to, let's save it to Mozart tempo. Okay, and I forgot to get rid of that print message, so I don't need that anymore. Okay, but let's go check out that file now, see if it did the thing I want. So copy it over from out. Mozart tempo, okay. So let's see. Gotta pause the music and hear the less nice music. So here's the original. Wait, no, that's not the original. Here. Okay. So that's the speed. I don't know if I'm clicking in time now that I think about it. There's a bit of delay between the microphone in and whatever the computer's playing, right? So I really should not do that. That's actually a problem I had when I was teaching remote. I was teaching music remotely at one point at the beginning of the pandemic, and yeah, that's not a good time to be teaching music. I'll tell you that much. The part of the problem is that the lag between like a Zoom call and between you and your student is enough that you cannot play anything in time. Like, it's just not possible. You just have to let them do something, and then you do something, and them do something. You can't play together anymore. So anyway, so that was the Turkish march. Now here's the version I generated, I think. Okay, and you can tell it's slow. It's way too slow. It's like half speed. So here. Yeah, okay, that's quite slow. Let's see if the Mozart tempo one fixed it. Yes. So that's the correct speed now. Still sounds like two skunks in a bag, but now it's doing the correct things at the correct time. So great success. Let's see if I can check off another thing here. Not quite, because I didn't fix the multiple tracks thing yet, but I did fix the tempo issue. So, you know, if you ever want to feel good about your to-do list, just add more things to it and then check them off. It's like, hey, I did this extra subtask. Yeah. Okay. And while we're at it, I will commit the code again. Not commit the code, just, you know, just create a new change. Fix tempo, the file tempo. Okay. And let's just see what's happening. Git log. There's my new fix. And if I look at what changed, git diff with the previous one, which was this one, 901, efdb. Oops. You can see what did I change? I added this print function and I just added this. That's all. Yeah, simple. Okay. I'm just gonna hide that. Okay. So let's actually tackle this to-do now. Now that we have at least everything at the right speed, we can probably handle this. So, here's what I'm thinking. I still want to save the tracks, just in case. I don't know what the purpose of the tracks are in MIDI, but I suspect they can go to different instruments, and I don't want to mess that up if I'm doing this. But at the same time, I want all of the note messages kind of in order of when they're played. So I still want to get the, when I'm doing this combining tracks thing, basically it's going to take notes from different tracks, which could be happening at the same time, and it's just going to list them all out in a row, basically. And so that gives you the correct timing for all the events in all the tracks. But unfortunately, it does not give you these relative times. So what we need to do, if I remember correctly, is there is some extra information in the tracks. So let me check what those are. Track. No, must be under tempo. Time. Yeah, so, yep, ticks per beat. That's what we dealt with. Where did I find this information? You have to divide by something. Well, there is this guy. Tick to second and second to tick. So let's try finding those two functions first in Midi. And I don't know where those are, so I'm just gonna search ticks. Oh, it's MIDI file, right? Let's see if it's under MIDI file. Nope. Maybe it's under track. Okay, this is where we kind of need the, let's go back to this. Oops, sorry. Midi. Let's look what's in this library to begin with. Tick to second, yes. So it has a function called tick to second and second to tick. Okay, and if I throw in something like that, okay, it needs two things, ticks per beat and tempo. Okay, I think we can do that. So let's go back to our code, and first thing to do is import those functions. It's called, actually we don't really need tick to second, we need second to tick. So if we do second to tick somewhere here, we need time in seconds. I'm guessing that's the float value we have. And then ticks per beat, that we should be able to pull from the MIDI file. Yes. Okay. So the MIDI file has ticks per beat right here. Okay. And then tempo. Okay. Tempo is microseconds per beat. So I'm guessing the track stores that. And I'm just going to confirm that. MIDI tempo. The default tempo is 500,000 microseconds per beat. And there's a meta message set tempo, which can change the tempo during the song. Oh no. Oh no. Okay, so this makes it a lot more complicated because as I'm scanning through all the messages, I actually need to be watching for set tempo messages. And just to confirm that, I suspect if I try to print out all the messages, I'm going to see some set tempos somewhere. So if let's try it right now. MIDI. Okay, so let's look for those, what are they called? Set tempo messages. Set tempo, yes, there's one. You can see right here. Set tempo, and then it tells you some important information. I think the important thing here is when you see that, it means everything after that message needs to be under the new tempo. And the tempo is this number, which is the microseconds per beat. Yes. Okay, so if we feed that in, we should have the correct tempo, hopefully. So I'm just doing this here, but really I shouldn't be doing it here. Let's create a new function to handle the tempo change. Def floats to int tempos, something like that. And we'll worry about what we need to fill in here later. Right? Here. Okay, so the important thing is we have some kind of float time, we have the ticks per beat, and then we need the tempo. And so basically I'm going to set tempo to the default, 500,000. And then as I'm going through all the messages, it'll go like this. For message in, track or whatever, you're going to do this, where message dot time, message dot time is the thing you're converting. This is going to be the ticks per beat, which I will need to bring in from the MIDI file. And so, and then this tempo value is going to be the default until we come across another set tempo message. So we have something like if message is set tempo message, then we're going to set the tempo to whatever that message is, which is what? Tempo. Okay. Apparently that's what it is. So we haven't created this is set tempo thing yet, but we can probably add that to note, I think, because note currently has is note off and stuff like that, is note on. So we'll just create another one that is for set tempo things. Def is set tempo message, and it returns a bool, of course. And here it's a meta message. So I actually don't know how to test whether something is a meta message or not. That's a really good question. Like, what does a meta message do exactly? Okay, time to do a little more digging. So we're going back to our experiment here. So I have the MIDI file, and some of these are messages are definitely those meta messages. So I'm just gonna copy out a couple of them. And okay. So I just stuck everything into a handy little array so I can look at the individual messages. Some of these are meta messages, right? Like this one. So I basically just want to know how do I get this value here in messages 1. So let's use dir again, handy dandy debugging tool. And it says there's a type. So I'm guessing if I go messages1.type, it gives me this meta message type. Excellent. And there's also an isMeta. That could be useful. So if I run isMeta, oh, it's not callable. Okay, so it's just a property, but you see, it gives you true. And I'm guessing if I do the same thing for something like message 20, which is probably a note message, it will be false because message 20 is a note event. Excellent. So now we know how to actually solve that problem we had, which is here. When you're looking for whether this message is a set tempo message, we need to check two things. One is that message.isMeta, and the other thing is that it needs to be a set tempo event, which let me just double check here. Yes, it's called set tempo. So that's the message type equals set tempo. And that's, if this is true, then we just return that. So I think that will do it. Okay, so let's take this and bring it back down to here. Floats to ints tempos. Float to int tempos. Let's fix the grammar on this. I mean, it seems silly to fix grammar when the computer doesn't care about grammar, but humans care about grammar. And if I don't do that, I'm just going to have issues later. So now I can call it this way. Note is set tempo. So this says if this message is a message about tempo, then I can update my current tempo to some new value. Otherwise, we need to check if this is actually a note on or note off message, I think. Right. Okay, so to do that, I think note already has some functions for that, which are is note on, is note off. So I can actually wrap these together for convenience into another method, static method. This is just for convenient. I'll just call this isNote. So it will return true whether the message is note on or note off. So in fact, I'll just copy this down and return is note on. Oh, I need to, or note dot, oops, is note off. So it'll return one of these two. It'll return true on either of these, basically. So whether the note turns on or off, it is still a note. And now I can go back down and say, here's our float to int tempos. And if it is a note, oops, we can run this guy. Now that I think about it, nah, we'll stick with this. This works. Okay, second to tick. So this should return the int time. Okay. I think the only thing left is to stick them into a track, and then you're done. So let's kind of go over the logic here. So if we're not combining the tracks, then you go through each track individually and you do the thing to them, which is you turn them into this 12-tone thing, right? Now, if you do the combine tracks thing, that's different. You're going to combine all the messages together, and then after you're done, sometime later, you need to stick them back into a track, basically, and kind of fix it up. So, here. So if you're combining all the tracks, everything goes into one mega track, but then at the end you would like to bring them back out into their original tracks. So I do need to keep track of which track each note came from. And then here, okay, I need a drink of water. Gosh, everything takes so much brain power. Even really basic things like this. Okay, so I don't like the way it's formatted right now, because you have this, you're kind of like combining these things together, and then you do this, and then you have to do something after that to fix the tempos. Is there a better way to do that? Okay, I'm going to do this. Right now we have this messages per track, right? That's fine. But I'm going to change up how I think of the tracks. Right now, these correspond directly to the tracks in the original MIDI file, but when I combine all the tracks together, it does not match up anymore. So instead, I'm going to store which track each message came from at some point, so that when I'm recreating the tracks, I can put them back in the correct tracks, if that makes any sense. So let's see. New MIDI.tracks.append track. Okay, where's this track? Map to 12 tone. Okay, so you can see right now map to 12 tone does all of the actual work here, and then it creates a new MIDI track and dumps all the messages into that. We're going to change this. Instead, we're just going to return all the messages. Okay, and then here we're going to break this track stuff into a new thing. Def like this. Okay. Cool. So why do this? Why split this up? Well, now we can control when we create that track, right? So we'll say messages equals this. And now if we were doing what we did before, we would just create a track, create track messages, and that becomes our track. And then we can append that to our new MIDI file. That's fine. But if we did this thing where we combine the tracks, we can change up this logic here so that before we create this track, we can kind of sort out which messages go to which things. So that means we're going to need some new object. Okay, and then basically we're going to loop over those again and kind of generate the tracks from there, I think. Let me think. So I think this is fine if we don't combine. But when we do combine, what we want to do is look through every message, assign each message to a track. Okay, I understand now. So what we need to do is basically kind of like multiplex, or what's the name? You know, there's an object in yeah, there's a funny word. We were just talking about this in class. Manifolds. Manifolds in computer science. Sorry, manifolds in mathematics are things that are like basically surfaces in like high dimensional space. It's like, for example, a globe is a kind of manifold, right? Because the surface of a sphere is curved. But there's another meaning to manifold, which is completely unrelated, which is like in cars, you have like a one tube that goes into like 10 different tubes and 10 tubes that go back to one tube. Those are manifolds as well. And so in this case, what we want is the second kind of manifold. We want to be able to take a whole bunch of different messages which belong to different tracks, smash them all into one track when we're combining them, but then later we want to go the other way. We want to go from one track and kind of distribute them out through this kind of manifold into multiple tracks. So basically this is kind of how it goes. What we say is like if args.combine tracks. So if they were all combined already, we run some kind of function which will messages equals split into tracks. I'm just making this up as I go, right? This is kind of the beauty of code. You can just kind of make up new functions as we go. And in this situation, the messages in tracks thing is going to have like only one object if there's only, yeah, because they've been all combined if you run this args combine tracks thing. Okay, that's really all there is to it. And then the last thing is to go through all the tracks, create each track and add them back to the MIDI file. Okay, cool. So let's add some comments just to make clear what's going on, because it's kind of confusing now. First thing we do is we copy all the MIDI messages into some array, and if we combine them, okay, we combine them all. Otherwise, we keep them separate, and then we create a new MIDI file. Actually, we don't need to do that until the end, so I'm gonna stick this like here at the end. Okay. So the first step is we kind of separate our notes into tracks. The second step is that we actually convert each track using the 12-tone map. So this is the magic, right? This is where we make the music sound bad. And then after that, if we had already combined them, split the notes, the messages back into separate tracks, if applicable. So if we did this combining earlier up here, we're going to undo it here, right? And then the last step is save each track to a MIDI file. So you can see the only thing we're missing is this guy here, split into tracks. So let's create that. And here, this float to in tempos thing will become relevant because we need to do that conversion in order to split everything back into separate tracks, I think. That's the plan. So here we are going to bring in a list of these messages. They're all mashed together. But I'm missing something. I also need to know what the tracks are, right? I think. Because I do need to know, right? Do I? No, I have all the messages, right? So what I'm thinking is the MIDI tracks don't store the tempo. It's the meta messages that store the tempo. So we don't need to know anything about the track. We just need the list of messages because those will include the meta messages, and those meta messages will tell us when things change, right? So float to end tempos is no longer going to take a MIDI file in, it's also going to take a list of messages. So here's the plan. We are going to look at each note assigned to its original track. So actually, now that I think about it, we can't bring in messages. It needs to be notes. Right? So what I mean is I have an object called note, and the note object tracks more than just the message. You can see this object of class note also tracks things like start and end for each message. And one other thing we can track here is which track it was from, I think. Wait, does that work though? That might be overloading this object too much, because we also have meta messages, which are just messages right now. Okay, yeah, that's not great. Okay, so what we need to do here maybe is save which track each thing was from. That might be a little tricky. That is kind of tricky, isn't it? Okay, time to do a little more digging. Back to here. So we have this MIDI, and you have all these messages in different tracks. Now, if I say, oops. Sorry. Messages equals message for message in MIDI. Okay. If I look at, that's too many. Okay, let's look at like the first 10. Well, we have a bunch of messages, but which track are they from? That's what I want to know. That's the problem. If I pull out the messages like this, it gives me the right time conversion, but unfortunately, it doesn't tell me where the tracks are that these things come from. Okay, back to the documentation. Iterating over a MIDI object, a MIDI file object, gives everything in playback order. That's what I want, yeah, for sure. Meta messages will be included. That's fine. That's totally fine. Okay. Don't care about creating. Yeah, I don't know if there's a good way to like, maybe there's a way to access things through the track instead of through the MIDI file. So let's try that. First let's list all the tracks. Wow, that's a lot. Oops, why is it not scrolling? There we go. Okay. So yeah, that gives me 2 tracks or so, and that's totally fine. Now, let's like look at the first track. Yeah. Okay. So this is some kind of track object. Let's see what the track object has. What I'm looking for here is some way to like look through the individual track items and basically get them in order of playing order. Actually, you know what? I bet there is some track information here, because otherwise how do you know which channel to play them out of? Okay, interesting. Let's try this. MIDI file itself, if I run that again, has different tracks. Okay, print tracks. What does that do? Okay, that just prints them out. Okay, I don't care about that. Okay, what I'm thinking is this is going to be kind of silly, but one way to kind of get around these issues is I could just match them up naively. So I'm just gonna look at the messages, and if they look kind of the same, I'll match them up. And the way I'm going to do that is I do need the tick to second thing, because when it's loaded up, when you get all the messages together like this, these give you float values for the time, and so I need to use mido.tick2second to match up the things to the right, these messages to the correct tracks. So that's the plan here. So I'm gonna, again, just create a new function to do this. Assign tracks, message array. And I'll also give it the MIDI file. Actually, I'll just give it this. Okay, and I will include the functionality I want under assigned tracks. So actually, let's call it combine tracks, because I have this function for split into tracks, right? Combine tracks. And we need two things here. Actually, just one thing. MIDI, just the MIDI file. And we're going to return two things here. One is the tracks. The tracks will be like a list of integers. It'll just tell you which track each message belongs to. And then the other one will be a messages list. Okay. Cool. We're going to need this function. So, time to import it. Cool. And what does this call? We need a tick per beat, and tempo. Okay. So let me write down the plan here first. We go through. First, we're gonna copy out everything to one track like this. And then we're going to go through each track in the file. And for each track, we're going to match up the messages. Something like that. Okay. And we can do this a little smarter. Instead of going through each track individually, we can kind of go through them all at once, keep kind of like pointer for each track to where we are currently, and we're just going to increment, one of the pointers at a time to when we match up the message. I think that's the best way. So let's change up the plan here. All tracks match up each message to one of the tracks, and then keep going until all the messages are matched up, basically. And to do that, the tick to second is important here, because that's what lets us match up the time of each note, like how long each note takes. Okay, so I'm just gonna fill this out for now, just so I know what's going on. We need a tick, which comes from the MIDI file. The tracks, right? Tick, I'll just leave it that way. Tick per beat should be from the MIDI, yes, MIDI.ticks per beat. And tempo is from, right, it's the same issue as splitting the tracks. The tempo comes from the track, and we need to keep hold of the tempo for some track. Okay, cool. So we're missing a lot of things here, but tempos is going to be some kind of array. In fact, it's going to be a very specific array. It's going to be the default tempo times the number of tracks. So basically, this creates an array of this thing repeated this many times. So we do need to know how many tracks there are, which is should be equal to midi.tracks and the length of this thing. Cool. Gotta take a quick break. Check for messages. Good. It's insane how much water you need to talk. I'm basically an evaporator here. That's my job. I'm just a really complicated way to evaporate water into the atmosphere. So number of tracks, we got that. Tempos, we got that. And then basically the idea is we're going to iterate for all messages in the message array. And then assign each one up to some of these tracks. So we'll do that. And so at the end here, we're going to tracks.append something, some kind of a track number. And we need that track number here somewhere. And so the idea is for each of these messages, we need to go through all the tracks and figure out which one contains this message. So the tracks should be in order, right? In time order. So that's fine. We just need to figure out which track to look at. So we're going to do another loop, an inner loop. So we're comparing this one to this one. So we'll call this message source. We'll call this message compare. Actually, no, for track and tracks. I'll fill out the tracks part later. And then sorry, I've already used this. So we'll change this to track IDs. Yeah, okay. So for each track, I've got some kind of like index here. So I need to create an index, which is like all zeros. Now for each track in tracks, I need the track index at that track. So actually, we'll change it up. We'll say n in range line tracks. Oops, I already have this. N tracks. Okay, for n, I get the current index. And that will tell me where I am on that track. So basically, this track's... why are these words so confusing? This keeps reference of where I am in any given track. So it's like a race, right? You've got... Each track is a racehorse. And so basically, at the start of the race, everyone starts at 0. And then if I pull out a message from this message array, it matches one of these guys. So when it matches that horse gets to move forward one step. And so that's what this is tracking. This is tracking where each racehorse is sitting currently. So they all start at 0, and then every time I match up a message, I get to move that racehorse forward. So basically, if message somehow I need some kind of equals function. We'll call it is same message and tracks. And so I need to pull out the actual track now. So midi.tracks and then I don't know if this is a list. So I need to check if this is subscriptable, but if it is, then I can get the track index at n. So that's the position that I'm at. This will give me a message from this track and bring that in. So this, I'll just separate it out like this. Message from track. If it's the same message, then we will do this. Track IDs.append n, our current track. So basically that says, okay, this message has this track number, and then we also need to increment track indexes. Wow. Track index at which position? N gets to go up by 1. And that's it, I think. So we just need another function called isSameMessage. Cool. And one of the things we're going to test is this tick to second. Okay, so let's see. Here at the end, we're going to return the track IDs and message array. Okay. Cool. Okay, so the only thing we're missing is isSameMessage. So there's a couple cases here. If it's a meta message, everything should be the same. If it's a note message, we need to convert the time part, because it could be float or it could be int, and we want the same. So let's do that. This is a little tricky. So here's why it's tricky. I need to check everything in this message. So let's see. Midi tracks messages. Okay, message 1. So you can see this is what a message looks like. We need to match up all the information in this message. So if I copy this message, I wonder if I can match up that. So we'll call this A, and we'll call message 1 the original B or something. And we just want to see if A equals B. Yes. Okay, so that's good news. It means that even if I copy it out, so long as the attributes are the same, they seem to be equal. Let's test that out. If I say a.key equals D, now I have a new message. You can see it's got key of D. And if I compare A to B now, they are no longer equal. That's good. Okay, so I think that will account for anything that's not a note message with those pesky float time values. So let's just do that. So basically, if note.isNote, so if they're both notes, we need to do this kind of conversion. So I'll fill out this conversion later. And then else, if they're both not notes, so okay, the problem is one of them could be a note and one of them could be not a note. And in that case, we need to do some other shenanigans. So let's actually do this instead. We'll convert each one separately. Convert time to int. Yeah, we'll just do that. Message A. And we'll do the same thing for message B. Actually, we might as well roll this functionality into this subroutine. And so now we gotta move this guy to the subroutine. Time to int. Okay. Still in progress. Oops. Hey, where's my key binding? Okay, apparently I cannot use one of my key bindings. It's annoying. But anyway, so I'm going to convert each one to int if they are note objects. So here I need to do something like if note is note message, then do some kind of conversion and return message. Okay, now here, once they are converted, we can just test for equality. I think that's it. Yeah, okay. So now here, if they're the same message, you're going to assign it. And then one more thing here is you can break the loop, because if you've identified one of these notes from the track, then you don't need to check the remaining tracks because you've already assigned that message to one of the tracks. You're done. Okay, so we are almost there. The only part that's missing is convert time to int. So the idea here is if I go back to my test example, I think there is a note object at message 20. Yeah. So you can see a equals message 20. Message 20 is note off, and it's got this time value here, right? And now if I open up a track, yeah, okay, so I just opened up a track and you can see that the message is here. If I go to, like, say the 20th message, there's a note, and you can see that this note has a time value, right? That's an integer instead of this float. And so basically we want to be able to compare these. How do we do that? Let's see. I have to do this conversion, right? I have to use the tick to second. Okay. So what are we missing? We need the ticks per beat. And the tempo. Okay, but now this looks like it's just this function being called and nothing else, but actually we need some extra boilerplate, which is if the time is already an integer, don't do anything, and if it's not a note, also don't do anything. So if the note is if this message is a note, and if it's if type of the note.time, sorry, message.time is float. So if it's a float time and it's a note, then we're going to do the conversion. That's how you do it, right? I forget. Okay, we'll find out. Tick to second. The tick... Actually, we don't want tick to second. We want second to tick. And the reason why I'm doing this is because with floats, when you try to compare floats, there's a little bit of uncertainty in there. Floating point operations get rounded off on the computer, so they might not be exactly identical, but I think the integers should be like, well, they're going to be rounded for sure. So hopefully that will allow exact comparisons here. And if it doesn't, I guess we'll find out and have to debug. So second to tick. We need second, which is message.time, ticks per beat, which we have, and tempo, which we have. Okay, so we no longer need ticks to second. And finally, we're going to set message.time. And I think that should create a new message, because the way Midi works is they copy out the message and they update this value in the new message, I think. I guess we'll find out. Will that be a problem if it doesn't update? So what I don't want to do is overwrite the wrong thing here. I can test this, actually. So let's do it right here. Equals message is 20. So there's our message 20. Now I'm going to set B to A. So right now B is referring to A. If I change A's time, A now has time 10. Now if B is referring to the same object as A, B will also have time 10, but if it was copied before it got updated, then B will still have the old time. So it doesn't look like that's happening. So I do need to make a copy. So if I do a.copy and then, so if I do b equals a.copy, a, b right now are the same, but if I go b.time equals 0.1, now that's correct. Okay, so I still need to call copy right here. So when I do convert time to int, I'm going to need to copy the time, sorry, the message equals message.copy, and then change the time. Cool. Okay, because I'm only doing this comparison here. I don't actually want to change the original messages. That's the issue. Okay, cool. I'm just gonna clean up some imports. I don't need tick to second anymore. Also don't need iterable, apparently. Okay, cool. So almost there, I think. This is a lot of work for like a fairly minor feature, which is annoying, but that's how it is. Float to int tempos. Okay, I might not need this anymore, because I can call this now. Yeah, okay. But what does matter here? So I'm gonna, yeah, that's not quite done, but let's ignore that. We have this, we have this. Oh, the only thing is I also need to update the tempo as we go. So as I go through these tracks, so the only time you need to update the tempo is when you look at a message and it's one of those set tempo messages. So if it's the same message, this moves up where you are in the race, right? Moves up this index, this pointer here. So what we want to do here is before it moves up, it also needs to update the tempo if that message is one of those set tempo messages. So here we're going to update tempos n with the new tempo, like that. Right. Yes. Cool. I think that's it. Okay, and one more thing. I'm going to get rid of is same message, should I? Because it's really only doing this. We'll leave it for now. Okay, so what's going on here? I think that's it. Okay, so I do need to change this up, but that can happen here, I think. So when you're doing the split into tracks, you're basically doing the same thing as combine tracks, but backwards. So first things first, right now we have two things here. So that's what we need in the undo button. Message array is this guy. Yeah. Okay. So basically we're doing this in reverse, right? Here you started with one MIDI file and you end up with a list of the source of each message, like the track of each message and the messages. Now we have a list of the tracks of each message and the message, and we want to turn that into one file. Okay. So how to do this? Well, it's pretty straightforward, I think. We have a T for track and then a message, and we're just going to iterate over everything. Track index and message, message array. Okay, and then for each message, we're going to stick it into a track. So tracks equals first we need to know how many tracks there are. So max track index is the number of tracks, And then the tracks themselves, we need to create a new MIDI track for each thing, for each of these end tracks. Okay, there's our tracks. Now, what we can do is we can say tracks at T appends. I think it's append, right? I think so. The message. That's all there is to it. That's easy. Of course, we also need to fix the time. Yes. Okay, so I also need to run convert time to int on this message. And I need the tempos, right? Yes. Okay, I'm going to change this t to n just because it was n in the other function. We'll keep it consistent. Message ticks per beat tempo. So we are missing ticks per beat and tempo. Okay. Ticks per beat I'll deal with later, but I do need to fix tempo here. And I do that here. Tempo equals that default value again. I really should split out this default value into like its own value. We'll call it default tempo.
Default underscore tempo WSL.
Whoa, that was weird. I did not know you could do that.
Default underscore tempo W.
What? I've never had this functionality before. Okay, interesting. Thanks, Windows. Thanks, but no thanks. Okay, back to it. Default tempo is 500,000, I think. Okay, where am I? Okay, we got that. Tempos. So tempos. Yeah, okay. So what happens here is it keeps track of what the tempo for that track is currently, and then if the message, here's where this comes in, right? If this is set tempo, if this message is a set tempo message, we need to update the tempo. And then the message, we just, if the message is a note and it needs to be converted, this will automatically handle that. Otherwise, it'll do nothing to it. Right? You can see if these things are true, it will change it. Otherwise, it just returns the same thing. So nothing happens. Okay. And then we stick that into the track and then we should be done. So after all that's said and done, we return the tracks, but you know what? Let's create the MIDI file as well. So we're just going to bring this code up. We create a new MIDI file. Yeah, and I'm just going to add the MIDI file up here. So that way, that's all the information you need. Yep. Perfect. So you create a new MIDI file copying all of these attributes of the old one right here. Messages. Now for each track, for track and tracks, I don't think I need this anymore. Create tracks. Yeah, I don't need this anymore. Yeah, cool. So that's going bye-bye. And we just need to add it to the new file and then return the new file. Yeah, nice. Okay, it's always good to erase code because that means you're making progress, right? You're getting rid of the old cruft. So I think now we can call this split into tracks down here. And actually first we need to call the other thing. This is no longer necessary. Combine tracks. So up top, you can see this guy. this guy gives you this. Tracks messages, right. And we need to bring these all the way down to here. New MIDI equals this. And finally, if args.combine, right. Okay, and the only problem now I have is that if this is not happening, we never called combine tracks. And that's kind of annoying, isn't it? It would be nice if this could do that. If we could do everything here. Okay, let's change this up a bit. We will keep this functionality down here. Oh, I guess I need to create track back. Okay, so much for erasing that code. We need it back. Where is it? A little after this. So sometimes you have to go through the undo and redo button to find the code. Okay, it's a little further back. There. Okay. Okay, so I still need to create track. Actually, I will probably just stick that here. Track and tracks. If args combine tracks, that gives you the new MIDI file. Or you create a new file, and then for each track, new track, MIDI track for message in message. This new track gets that, and then the new MIDI appends that track. Okay. Yeah, let's do that. And then the only thing we need to do is save. Okay. Yeah, okay. So this will be common logic, which means this split into tracks is going to give you whatever this thing is, which we call messages in tracks. Okay. So let's go back up here. Now we are no longer returning this MIDI file. Instead, messages in tracks is a list of messages. So the first list is all the tracks. The second list is the messages within each track. So we do no longer need this. Instead, we have tracks at n append message. So that means we are returning tracks. Because tracks is it's already a MIDI track. So we actually don't want that. Right. We actually just want an empty list. We want n empty lists. I think you can do that. Yeah. So what this does is you have a list of a list, and then you're multiplying that out n times, so you end up with n empty lists. I think. Need type annotation. Can I do this? I mean, it's perfectly valid, I think. Okay. Let me just check my messages. We're good. It's 10:30, so I have to think about like how much else is going to happen, because this took a long time just to handle all these tracks. Okay, I think it's debugging time, so I'm just going to jump right in and do some debugging. Hopefully things work. I guess we'll find out. Okay. Moment of truth. We're going to exit out. And actually, we're just going to run one of the earlier commands, like this. Okay. And of course, I missed some really obvious things. For message in, messages. For track. Right. So what is this? Okay. Wait, no errors? There's no way. That's really suspicious, you know? It's always suspicious if your code just runs. Right? That seems really like something went wrong. I'm so suspicious, I'm going to print out some statements just to see what the heck's going on. Okay, it's printing, so that's a good sign, right? I'm just gonna see what's going on here. Okay. Oops. So here's the original Midi file, and I'm just going to check that things are correct. I mean, it looks about right. I mean, everything looks fine. I'm also going to print out one other thing, which is... right, I forgot one important thing, which is where these tracks are from. So I'm going to print out this... I'm going to change the name as well, so it's a little more obvious what this is. Track index. So this tells you which track each message belongs to. See what that looks like. Oh, I see. Okay, the reason why it's not working is because I forgot to set the combined tracks flag. So it's using the old functionality, which is it doesn't use this combined tracks thing. So as soon as I do that, I bet a whole bunch of new errors will show up because it will be actually running the new code. And sure enough, there it is. So ticks per beat. Convert time to int. Aha, okay. So I forgot to give it some information about ticks per beat and tempo. Let's do that. Tempos n. Okay. Do I call this anywhere else? Just once. Okay. This index out of range. Okay, this is the kind of debugging that I expected. So when you're splitting into tracks, it's trying to convert time to integer, and this n is out of range. Okay. So whatever this index is too far out for tempos. Interesting. Well, I mean, here's an easy way to check. Tempos, just print it out. And for each of these, print out n. Okay, so let's see. Here's the tempos. Wait, why are there so many? That sure is strange, isn't it? There are 167 tracks. Okay, that's definitely wrong. So this track index is screwy, which means something happened when in combined tracks. Right. Oh, I'm returning the wrong thing. It should be track IDs. Okay, that explains a lot. So let's rename everything to track IDs. including here. Okay. Okay, that looks a lot more reasonable. Cool. It's still running some errors. 185 split. Print N. Okay, tempos. There's only one track apparently. There's only one track. Okay, I see. N tracks is max plus 1 because this track ID thing goes from 0, right? So 0 indexing means if you have 2 tracks, it's 0, 1. So the number of tracks is 1 more than that. Okay, yes, that works. So now we are onto a different error, line 221. New MIDI can't append track because track doesn't exist. Okay, so it's called new track. That's why. Oh, and I should get rid of these print statements. Cool. Back to it. Line 222. Line 222. Oh, I changed it. That's why. Okay. It's line 219 now. When it's trying to save the file, there is still an int. Oh, I know what happened. So when I did the conversion, where does that happen? Second to tick. I'm guessing this is still a float. Let's test that. Yeah, so even though it converted to ticks correctly, what it did not do was convert the type. So it's still a floating point number, even though it can be an integer just fine. So we need to cast to an int, which we can do like that. Okay, now if I run that again, still got an error. Why is that? Okay, you see, those are integers now. But somehow I am getting something that's not an integer. I'm just gonna check that when I run convert time down here, I'm still getting integers. Almost. Okay, I see what happened. There are some meta messages which also have times, and those did not get converted. So we actually need to change up how convert time to int works. I think what we need to do here is just instead of testing that this message is a note, I'm just going to test that the message contains this time attribute. So if time in message, something like that, right? Let me double check. Python has attribute. Actually, it's has attrib something. Right, yeah, it is. It's called has attribute message, and the name of the attribute is time. Then we can just roll that into one statement. If it's got a time value and the type of the time is float, then you're going to copy out the message, set the time to this int conversion, and then return the message. Okay. Yes, now it runs. Any print statements? Nope. Okay, so I think it worked. I'm just going to print out the entire output again just to check. Just to make sure there's nothing screwy happening. So here's all the... Actually, you know what? I'll print out like the first couple messages. So here's where that print MIDI messages thing comes in handy. We're going to run that twice. Once on the old one and once on the new one. MIDI. And once on new MIDI. That way we can compare them. Okay. So here they are. Okay. don't see anything wrong, so that's promising. The meta messages. Let's see, here's one. Here's a note on. Yeah, the problem is it's actually giving me slightly different messages here. I wonder if the timing of these messages got mixed up. Okay, let's go through them one at a time. So here's the first 4. They're all meta messages. Here they are the same. So the next ones, program and control changes up to 16. So here we have also up to 16. Cool. So those are the same. But after that, 17 is a meta message for a track. And then there are 2 notes. But here there's 3 meta messages. That's not good. I'm guessing these came from... Okay, actually I don't know. I'm not guessing, so I'm going to print out a few more. Let's do 25 instead. Okay. Wow, that's a lot of control changes. Why are there so many control changes? That's very suspicious. Okay. What I'm going to do is actually allow myself to print a little later. We'll do 30. So I need to change print Midi messages to account for start. Go. Oh, I can't do that. Because that's not how that works. Okay, so what I need to do is like by less than start. There. Okay. Okay. There. So here's the first file. Okay, here's the second file. So I still cannot find. Okay, I'm gonna print out a few more. Like I'm gonna print out to like 15 or so. Okay, I finally have note messages. So here is the second file. 36 is the first note message. Okay, and it's got a time of 0.5. Let's just compare that with the first note message up top, which was way earlier. Okay, I can't even see it. That's how early it is. So I just have a whole bunch of extra control and program changes somehow. And they look repeated. It's like this looks like the same message as that. So it just got copied out a bunch. And I have no idea why. Okay. Ugh. Classic problems. So maybe what would help is if I also print out the track IDs. Okay, so the track IDs, you can see there's 1, 2, 3, 4, 5. 5 messages that go in track 0. And I think the problem is that we're not getting that. There's actually a way to find out, which is for each new track, we're going to print out the new track. Okay. Okay. Yeah, okay, so you can see there's a pretty clear issue happening, which is that both tracks seem to have all the messages right now. So you can see there's 5 meta messages, and there's also 5 meta messages. So everything's showing up twice for some reason. Okay. Why? Why is that happening? Split into tracks. Must be happening when in split into tracks. Right? So for N and message, okay, I need to look at what this guy is coming out with. Split into tracks. Okay. Ooh, that's hard to see. Okay, so it's a little hard to tell what's going on, but what I'm looking for is where does this end? So maybe I'll just print out the length of each thing. Yeah, they're both the same length. So the issue is already in split to tracks, where this guy is supposed to... Oh, I know what happened here. Okay, so the problem is this is actually the same list getting repeated n times. So what we need instead is something like this. So we need a separate list. Okay, that should fix the issue. Okay, yes, it fixed it. So you can see now there's 5 things and 167. And if I print out the first couple, I think we will see the correct thing going on. So let me do that real quick. Print MIDI messages, new MIDI, and MIDI. And these should match now. Let's see. Oops. I think they're the same. Yeah, I think they are the same. I'm just gonna print a new line in between just so I can see what's going on. There, okay. For some reason it's printing a little bit extra. Oh, because because I put it in the loop, of course. Okay, that fixes everything. Cool. And they look identical. Yes, success. Everything's the same. So that was a lot of work, which probably has 0 impact on how this thing sounds in the end. But now at least I can say it's working correctly. And so for the rest of today, I think I'll just... first of all, I'm gonna actually run it and make sure that it works on an audio level, and then after that, I'm gonna try implementing some more fun stuff like different scales, and I think that's all the time I'll have today. So let's take a look at this. Here's the new one, Mozart tempo. Place. Okay, let's just give it a quick listen, make sure it's working. That's definitely not working. So nothing happened to these. Why is that? Odd. So it did not actually convert the 12-tone map. Oh, I see. It's because I reset this. I see. Okay. So I need to get rid of that. It's called messages in tracks. Wait, what? Okay. Just some naming issues, that's all. And it froze. That's not a good look. Okay, let me think about what's going on here. So... yeah, okay, something's going on. Set pitch is going haywire. I'm gonna try it without combined tracks first. Okay, it also freezes, so something screwed up. When I change, so I have, for some reason, I have a brand new thing called messages in tracks. Oh, I see what's happening. Okay, I need a new output, that's why. Okay. I see, okay. So this is the output. Okay. Okay, I'm just sending the wrong thing here. So split into tracks. What does it need? It needs a message array, which should be this guy. Okay, there we go. I see what the issue is. Okay, so the problem was that I was just sending the wrong thing into split into tracks. So now it should work. And I'm just going to rename this because that was really confusing. So this is the input messages, and this is the output messages. Cool. And just make sure that's still working. Cool. And let's check what it sounds like. Yeah, that's the correct file. So nothing has changed about the output, but now we can handle multiple tracks. That's all that happened. Okay, that's enough of that. Cool. Let's see what time it is. Yeah, it's almost 11. So let's go back to the list. Allow permutations across multiple tracks. Technically that is done, even though it has not affected the sound of the tracks I have, because they don't use multiple tracks really, but that is done now. So that's great. There's some other ones, which I'm gonna skip over because those aren't fun. I think other scales is fun, because that'll sound different. So let's do this one. We're gonna skip over these and jump right into here. Actually, I do have an idea for this. It'll be a quick hack to make this happen, but let's focus on other scales. So, oops, I'm just gonna swap these two windows. Okay. And of course, I should probably update my file. So the changes are... Cat alert! Cat alert! Hello, Tess. Where are you going? Cat's hiding into the box beside the computer here. Okay. You do you, I guess. So, let's see. Let's see. What did I update? I updated a bunch of code. And the purpose was to add combine tracks. I think that's it. And we'll say fix float to int time steps for messages. Okay. And if I pull up that, I cannot see where I am on the keyboard. There we go. Okay, if I do git log, oops, git log. Cool. Okay, great. So one more feature for tonight, which is just going to be the different scales. So I think we're going to, this is how it works. Okay, I'm going to have a custom scale option. Should I do that? Let's just have a few presets. That's easier to program, I think. So scale will be it's going to have some default values, so I do need to look this up. How do I get argparse default values? Oh, sorry, not default values, but options. Argparse options list. Stack Overflow to the rescue. It says description or choices. So you have choices. Cool. So we're gonna need some kind of object called like scales, and it's going to be some kind of dictionary, and it'll have a name for each scale. We'll call this chromatic. That's the default one we have. That's all the notes, and we'll just use this kind of notation of 0 to 12 for the chromatic values. So if we have like hexatonic, let's start with that one, also known as whole tone. That's going to be, so that's going to be every other note. So it should be 0 to 12, sorry, and every other one. So 0, 2, 4, 6, 8. So fourth. Okay. What else do we have? Let's do octatonic. Octatonic I should just list out. 0, 1, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the octatonic scale has 8 notes, 1, 2, 3, 4, 5, 6, 7, 8. And basically it's like you take a small step, then a big step, small step, big step, and you just alternate. Right? And we'll do a pentatonic because that's fun. And that will be 0. We'll do the major pentatonic. So that's going to be 0, 2, 4. So the major pentatonic is like do, re, mi, and then skipping so, la. So we have do, re, mi, and then we're going to skip fa, which should be 6. 7 is so, and then la is 9. I think, because from there back to do is a minor third. Yeah, okay, that's good. So there are my scales, and the choices will be scales.keys, and we need to turn that into a list probably. And the default So the only thing we need to change when we're doing this is in the map to 12 tone. Here, we need to have a new option for how we handle these different scales. So now, you see, this is why I used n equals 12 here, because now I can change n. So instead of having n equal 12, now it's going to be the length of the scale. And other than that, there's probably something that's like range to n, which we need to change. Real pitch, tone row. All right, tone row here. So tone row is no longer going to be the range from 0 to n. Instead, it will be the array of the scale. Yep. And now that I think about it, yeah, that's fine. Cool. Okay, so that should just work. Like, it's only 2 changes. Now, down here, we do need to pass it the scale. So we're going to say args.scale, but that's just the name of the scale. So now we need to map it to an actual array. And we do that using this guy, scales args.scale. Cool. Okay, so let's try running that again. Got an unexpected keyword choices. It's interesting because according to this, choices is what we need. Argparse, add argument, choices. I wonder if I'm using an older version of Python or something and it doesn't have that. Let's find out. Yeah, it's got choices, yeah. Maybe I need a type. Let's try that. Okay, that's a little weird. I'm gonna leave out choices for now. Okay. Oh, action. That's why. Somehow I forgot about this. You can't set action store true because that's assuming that you want a boolean here, right? We don't. So that's great. I did not define this apparently. Oh, I just misspelled it. Okay. There. Okay. So if I now call the same thing, but I'm going to combine tracks. Okay. And also, I'm going to change the scale so that it is, let's call it, let's do the pentatonic, because that's going to be quite dramatic. Cool. Let's see what that sounds like. I really should create a script or something to automatically copy things over, but we'll call this Mozart pentatonic. That's interesting. It sounds different, but it doesn't sound right. That's I might have just gotten the notes wrong on the pentatonic. Well, let's try the hexatonic, the whole tone scale, because I definitely know that's correct. I'll just call it whole instead of whole tone. Okay, and let's copy that over. Okay, so I think that one worked, but they are sounding a little off the pentatonic scale, so I don't know exactly what happened. And also it's getting cut off really early, so I'm not sure why that is. But I mean, hey, it's a proof of concept. It kind of works. So maybe something's going on here. I'm just gonna clean this code up a bit. Map to 12 tone. Scale. Okay, so N is set as the length of the scale. The tone row is the array from the scale. Okay. Then this is N by N. Yep. Why is it so short then? I wonder if I'm putting in the wrong input as well. Let's see. No, that's fine. Okay, I'm not sure what's going on. Let's see. Make sure the scale's correct too. Whole step, should be minor third, so 3 steps. Yep. Whole step and then minor third. Yeah, that's fine. Okay, that's fine. Sets the chromatic. Okay. Okay, yeah. Here, this is definitely wrong. So I'm surprised that's not calling an error here, which kind of seems suspicious, right? Because there aren't that many notes anymore. Actually, no, that's fine. Yeah, okay. Because this N is not going to be the same when you have a different scale. Diff from real. Yeah, that's fine. That's all fine. Yeah, that's weird. Okay. Let's just try running it again. Maybe on the test scale. Because that's a little shorter. So let's try running test scale mid, and we'll output to test. Okay. And we'll also do whole tone, just so I have some comparison. Okay, and now let's open those up, and I will use MuseScore this time. Here. Okay, so here's the original scale. Yeah, that's pretty straightforward. Okay, let's look at the whole scale. So the whole tone scale only has 6 notes, so it should repeat after 6. Here's 4, here's 2. So it should have used everything in the whole tone scale to here. And then here, it should reuse them. Somehow, for some reason, there's an extra note here. That's weird. Yeah, that's weird. It should not be repeating the C here. No, there's actually 3 repeats. But after that, is that good? No, that's still bad, right? There's just a lot of repeats for some reason. Okay, so there was 6 notes. Here's the next 6, and it's missing a bunch. My guess is something about the assignment of the notes is wrong. Okay, let's look at the pentatonic version. Yeah, it didn't do this at all, you can see. The pentatonic scale only has like these 3 notes, and then these 2. So somewhere along the line, stuff is going screwy. Let me check. Messages, good. Okay. Okay. I'm going to use this test scale to investigate what's going on inside this map to 12 tone zone. So here. So basically, you have a bunch of groups. Let's start by making sure those groups are what I think they are. Okay. Let's do this. Okay, there we go. And I just realized instead of doing this, I could use print Midi messages. Cool. Okay, so the groups are the correct length. You can see there's 5 things, and another 5, and another 3. Okay. Next, what happens after the assignment? So, we're going to check a couple different things. So let's start by checking real pitch. So, and the tone row, which is what we generate. And finally, we'll check diff from real, which is the difference between the real pitches and the tone row pitches. Okay, so here's the first one. That's a scale. Here's the whole tone version. And here's the differences. Okay, that seems fine. Now here's the scale. Here's the whole tone version. Ah, okay, so something went wrong here because it should not be giving you the same thing back. Okay. I'm gonna print 2 more things, which are the indices it assigns. So real, tone row, indices. So here, okay. So here's the real ones. Here's the tone row. Here are the indices. So this index is different. Okay, I see. I should be printing permuted. That's why. Oops. Okay, yeah, that's better. So you can see here's the permuted version. 4, 0, 6, 10, 2, 8. So that's good because you can see these are, these are pretty reasonable. So it's just a matter of making sure that. So basically what this means is I'm assigning the correct pitches to things, but I'm getting the differences wrong. So it's going to the wrong notes. So the issue is this diff from real. Let's take a closer look at that. Oh, there we go. Oops. Okay. Okay, so the differences here. These differences are fine because these are just 1 higher. Okay. Here though, this says it's 1 more, and that's clearly wrong because this is 11. This is 4, so the minimum difference in clock arithmetic, in modular arithmetic, should be like 5 here. So why is it not giving me 5? Problem is mod diff here. So the problem is this function here. Okay, so let's take a look here. Mod diff, print x and y. I'll print a, b, and sign. And see what's going on here. So here's the first problem. I think 11 to 4. Why is it getting run so many times? It should not be getting run that many times, right? Yeah, why is it doing that? Okay, I see. Maybe something's going on here. Yeah, that's fine. Okay. Is it getting called somewhere else? Oh, it's getting called here, that's why. Okay. That explains it. So we'll just print a big break here. Okay, so here's the ones we care about at the bottom. No, sorry, no. We'll go up a bit. I'm gonna print this. Yeah. Ooh, okay, here, this is the ones. 4, 0, yeah, here. Okay, so we have 4 to 11. Okay. So it should be the smallest of b minus a or a plus mod minus b. In this case, let's just print those out directly. Okay. A plus mod minus b is the problem. So it's the mod part that's the problem, this n. So this n should be 12, not whatever it is. So the reason why is this n is currently the length of the scale, right? But for this modular difference to work, the modulo difference needs to be in terms of the clock arithmetic we're doing, which is modulo 12, because it's chromatic. So that's the problem. Okay, anywhere else I call this. Mod L2 loss is the other place. Yeah, I'm just gonna set that by default. That should fix it. Let me just double check. Yes, because now the difference is 5. Okay, and I'm just gonna print the diff from real now. Oops. Okay. Five, 0, 6. This one, that looks better, right? 11 is B below middle C. This is E above middle C. That's the closest distance from B to E. So the differences should be, let's see. The differences here are what you have to add to this to get that. Okay, so here you have to subtract 5 to get this. Is that correct? B down to E. It should be up to E though. 5 plus 1 is 6. Right? 10. 11 minus 1 is 10. That's good. 11 minus 5 is 6 though, not 4. So that one's wrong. Nine minus 5 is not 2. 9 plus 5 is 2 in modular arithmetic, because 9 plus 5 is 14, and then subtract 12, yeah. Okay, so the signs are wrong, but at least I'm going to the right distances now. 7 plus 1 is 8. That's good. So the sign is wrong. Okay. So let's think about the, I kind of did this like a hack last time, so that's why this is screwy now. Yeah, so I'm just gonna fix this and then that'll be it for today. Let's see. Sine is minus 1 if x less than y. So actually the sign depends on which side's shorter, basically. Like you can think of the clock as like this. You can either go clockwise between these two numbers or counterclockwise. And it's going to be between A and B, of course, right? And so, why is that situation breaking? Let's see. So in this case, we have 4 and 11. So this is 4, this is 11. Right? Oops. This is 11. Okay. It's giving me minus 5. So first of all, So first of all, A is 4 and B is 11. That's fine. Now, B minus A is 11 minus 4, which is 7. So you're going to have the minimum of 7 or A plus mod, which is 12. Right, so 4 plus 12 minus B, which is 11. So that would be 16 minus 11, which would be 5. Right? Okay, so clearly 5 is less than 7. So we should be going from let's see, so B minus A would be like going this way, backwards along the clock. And then A plus mod would be like going that way around the clock through the 12 o'clock position. So I see why. The sign is not just dependent on whether x is less than y, but also on which of these is smaller. I think that's the part I'm missing. So, So I think we can do something like right, clockwise would be it's other way around. Clockwise is no, sorry, that was correct. Clockwise is B minus A, and then counterclockwise is this way. Okay. Yeah, because B is always bigger than A. So if you place them on a clock, going clockwise means you go this way. Yeah. The counterclockwise is above. It doesn't really matter which way you think of it. The importance is that the direction depends on which of these is smaller, right? times some kind of sign. Otherwise, return ccw times some kind of sign. Okay, so now we need to think about the sign. So in this case, you have B, which is further along the clock than A, right? And basically that means that, let's see, the difference is positive. Unless X was the smaller value. So if you assign X to A and Y to B, you're fine. But if you assign them the other way, you need to multiply by -1. Okay. And then here, if it's counterclockwise, you need to flip the sign for this, and then do the same thing. I think that's the way. So we don't need this anymore. Something like that. Looks promising. Now this is positive, so 11 plus 5 modulo 12 gives you 4. This is 0 and -6. Okay, and then yep, that's fine. This is 11. Nine. Hang on. 11. All right, 11 to 10 -1. Good. And 9 plus 5 is 14. Modulo 12 is 2. Yes, good. And 7 plus 1 is 8. Okay, so I think that fixed it. It was just a sign issue. So now we'll get rid of that print function, and let's run this on the test scale again. We'll run pentatonic and whole, just those two, and check what it looks like here. Okay, we can close these. And load them up. Okay, that looks a lot better. Let's see. Here's the first 6 notes. They're all different. The next 6 notes should also be different. Which they are. Good. Now, these intervals are kind of screwy, but that's how it is. And then the last ones we don't change because it doesn't account for partial matches. Partial groupings. Okay, here's the pentatonic version. So here's the first 5 notes. They're all distinct. Good. Are these all distinct? Yes. And here's the last 5 that it does. Well, that's a little bit weird. It's a bit of a weird match at the end here. I'm really surprised. That's a little weird, to be honest. If I look at the original scale, the last couple notes are... We're talking about everything except the last note, so these 5 notes. Apparently it's closer to match them up this way then. That's so weird. Why wouldn't it just match them up? Wow, that is so strange. Okay, this is one of those things where it's technically working, it's doing things which I don't think are optimal, so I'm just gonna check what's going on at the end. Okay, I'm gonna print out the real pitch first. What I'm looking for is the last 5 notes, which should be FEDC, sorry, no, GFED, AGFED, those are the 5. Yeah, these are definitely not the right notes. Oh, I see. I'm converting the wrong one. Okay, test scale, penta. Okay, that's better. 97542. Yes, that's that ending bit. Now it thinks it should map to 42097. So why didn't it just map these to these? 420. Yeah, that would be a lot closer, wouldn't it? It's crazy. That's crazy. So I wonder if the issue is the losses. Actually, I'll just print all of the losses. Okay, here's the losses. Okay, for some reason the first loss is huge, that's why. So the other ones are fine, but the first one is huge. So apparently the distance from that also does not make sense. Oh, it should be this diagonal. It should be the, yeah, because the notes here are ordered like 0 to 4, 7, 9. So, right, so we want that basically in reverse order for this match. So it should be this match 4, 4, 1, 0, 0. But instead it gave a different match. It gave 42097, which would be like this one, this one, this one. Huh. I wonder if I got these wrong. Real to tone. That's my loss. I wonder if I'm actually, I have these like the wrong way around. Well, you know, here's a really stupid way to do it. I'm just gonna swap around. Yeah, no, that's still screwy. Okay. Okay, so that was the wrong hypothesis. What's going on here? Oh, I see. I forgot this. That's why. Okay, I was wondering what was going on with this. So, that's why. Okay. Yes, that's much better. Okay, so I basically just forgot to throw in a 12 for this loss function. Instead, it was giving it n, which is 5 here. But it needs to be modulo 12 because we're working with the chromatic scale. That's how we're naming these notes here. So down here in this mod L2 loss, this is why this mod needs to be 12 here at all times. Okay, so that should fix it. And so after I run this on the pieces again, I think I'll call it. Let's do the test scale first. Okay, and we'll load her up again. here they are. Yeah, that looks a lot more reasonable. Here's the first 6 notes. Here's the next 6. And here's the first 5. Here's the next 5. Here's the last 5 that it does. Hey, okay, that looks a lot more convincing. Let's give them a listen. So the original scale would be this. Now in whole tones. Okay. And in pentatonic. Oops. Starting here. Alright, great. Let's try it on the other pieces now. So, I will, let's write a quick script to do this. Yeah, okay, let's add a quick script so that I'm not waiting around for this. And it will run Python .py. With some arguments. So what are the arguments? We need the input, output. We're going to use combined tracks by default, and the scale equals something. Scale. Okay, so input. So we're gonna do something like for file in source do this. So we need a source, and that will be probably so I'm just going to loop over all the files in some directory, which will be Midi. We'll call this Midi dir. The input will be this file. And the output will be outdir. And we also need the scale. So, okay, so this is just automating, you know, we're going to generate all these scales and all of these files all at once. And so we need one more, which is done. And we need one more for loop. Like that. Okay. The scales are going to be chromatic, all, pentatonic, and octatonic. Okay. Oh, and I need the... I always forget how this script thing goes. Help me, Stack Overflow. Exclamation, pound exclamation mark slash bin. So pound exclamation mark slash bin. And I believe that just tells the computer where to look for the program to evaluate the script. So I should be able to just run convert midi.sh with one more thing. I need the outdir. Okay, so first thing first, I'm actually going to empty out the outdir. So so it's empty, and then I'm going to try running convert, which I need to allow myself to run first. So I'm changing the permissions to allow execution, and now I should be able to run it. Okay, unexpected. Bash array. Okay, I think to access the array, bash array for loop. Okay, I have an array, yeah. Then to loop for I in, okay, so the part I'm missing is this. I need to do this, like that. Oops, still having issues. Syntax error. So actually the issue is here. I don't understand. What is the issue with this? Is it that these are not? Nope, that's not the issue. Okay, you want always do this. Nope, still an issue. Okay, what is up with that? Oh boy, okay, this is my bash newbiness showing. I guess there's always the hard-coded way. So I will just use Python to do this instead. That's easier. Okay, so okay, I'm gonna split this out. Combine tracks. How many are there? Okay, so we just need to okay. So the reason why I split out convert is now I should be able to just run it multiple times. So let's do that. So we'll have a special one called all. Basically, I'm just hacking this so that if args.scale equals all, what we will do is we'll just run convert on every single possible scale. So it will be for scale in scales keys. Right. This needs to go on top, and we are going to save it as like that. Okay, I'm just gonna do this, so let's do this. Okay, almost done. So I'm just cleaning up an interface to allow me to generate all the scales at once, because I don't know how to work with Bash, apparently. So instead, I will use Python to do the same thing. Okay, and then for scale in scales, we run this. That's it. Okay, so if we go back to here, we don't need the different scales anymore. We can just oh dear, will be yeah, okay. I think that'll do it. We don't need that. Oh. Yeah, these things indicate you can skip the line over. Okay, and apparently it's not a valid choice because I need to include that as a choice, right? Okay. But we can't find MIDI test scale, right? Why is that? Okay, I see. Because this guy includes that. Okay, so we just need that. Not callable. Oh. Nope, that's fine. Convert. Ah, okay. I see. The problem is this this is a function, but it's also the name of a variable, so we need to change it. We'll call it do combine. Or just combine. We might as well change it all. Okay. And here too. Here all. Okay. Where's that happening? Okay, somehow it's getting all as a scale, and it really shouldn't be. I see why. Should be that. Okay, POSIX path. Ah, okay. So I need to change this output path. So this is a POSIX path, and what we need is the let's just do it this way. Like that. What is this output? Okay, that's not great. What we really want is... I see. Okay, the problem is the output right now has a lot of junk in it, so... This outdo does not work well. Okay, I see also. There's this issue. Okay, so it really should just be like this. Now, it still doesn't have that directory, but we're closer, so we just need to create the directory, that's all. Although I don't really want... Okay. Okay, so I'm having trouble with the output. So you know what? I'm just going to give it an output directory instead of a file name. That's easier. Yeah, okay. Stem. Okay, so that way... Oops. Okay. After long last, I think I've got it. Yes. Okay. That finally worked. It took a couple tries, but we're done. So, let's take a look. Oops. Let's search through here first. So we have an output zone, and the outputs include... Yes, the outputs have everything. Now, I don't like that these things don't have a break between them, so I'm just going to change the file names very slightly so that it's the stem of the file plus dash plus the scale. So let me just remove everything here and then rerun that. Ooh, okay. I think that's enough for today. Holy crap. So after this, I'm just gonna listen to what was created, and that'll be it. Let's take a look. Yes, so now we've got all the different versions. Okay, time for the bonanza. Let's go listen to some of these. Okay. So output. First up is Bach. So let's listen to the original. Okay, and here's the special version. Let's see. We have the chromatic version. Okay, so that didn't work. Hang on, there's only one note in that? Okay, let's try another one. Okay, that one's also broken. Let's take a look in MuseScore. Yeah, it only has one note. Okay, so that one broke. Uh-oh. Well, let's try Beethoven. Hopefully that one didn't break. Original? Okay, chromatic. Did that break as well? Uh-oh. Yeah, that one didn't save anything at all. Okay, that's really weird. That is really weird. last minute bug. I refuse to be defeated, so I'm just gonna try running. Right. Just scale hole, okay. Out, test scale, hole. Okay, yeah, that worked fine. Let's try running all. So those are all the test scales. Now I copy them over. Okay, and let's open them up. Okay, that worked fine. So what happened? What happened to the other ones? Let's try. Okay, let's remove everything first and then run it. Okay, so those are the 4. And let's open up in MuseScore. Okay, I mean, that worked. Right? Let's try playing them. So chromatic. Okay, that works. Okay, let's try the Octatonic version. This will also sound bad, but different bad. Okay, this is pentatonic. It should sound much better. Okay, and finally whole tone. I mean, they all kind of sound like unintelligible garbage, but I can tell that at least these are the correct scales. So it did work for that. It's just for some reason it didn't work on some of the other pieces. The Beethoven and the Bach did not work out. Let's see if the Chopin worked out. The Chopin did not work out. I wonder if it's like something wrong with the script. So I'm just gonna try running it this way. And run them over here. Yeah, so for some reason it didn't work on some of these other pieces, so there's still a bug, but it did work on at least a couple of them. So I will call that a moderate success for today. I'm going to save out this code, and I think that'll be it for today. So let's just save it out. What did we do? We added scales. Okay, so add different scales. And we also added a script. Okay, that's it. And let's call it there. So next week I'll be starting a brand new thing. That will be the other project. Yes, let's see. Yes, talking piano. So the idea behind that one is going to be we take a piano and try to mimic the sound of something else. And there is existing code for this. I just took a look online today and found some, and I think it does some naive matching up of like the peaks between the spectrograms. And I'd like to do something a little more sophisticated, so we'll see how well that goes. Who knows? And I'll see everyone next week. Have a good one.